Next, we will learn how to calculate the regression equation. Y hat equals to bx plus a. B is the slope and a is the intercept. The equation for b is the ratio of covariance of xy and the variance of x. So we need to find out the covariance and the variance of x. Then for the intercept, we know that this regression line always crosses the point of y bar and x bar if we know the mean of y and x, and if we know the b, then we should be able to figure out a. So the procedure is mean of y equals to b multiply mean of x plus a. Then b multiply mean of x plus a equals to mean of y. Then a equals to mean of y minus b multiply mean of x. So that is the equation of the intercept, the mean of y minus the slope multiply the mean of x. Let's look at a data set. It is the x is the SAT verbal scores and y is the GPA, freshman GPA. So this is the scatter plot based on these 5 students' grade. X-axis presents SAT scores and the y-axis presents GPA. Then we need to find out this regression line that best presents this scatter plot. So we need to find out, again, first we will compute the mean of x and the mean of y. Mean of x is 616. Mean of y is 3.2. Then we find out the deviation scores for x. Each x minus the mean of x. The first one is 630 minus 616. We will have 14, 84, 174, negative 106, negative 166. Then we find out the deviation scores for each y. The first one is 3.0 minus 3.2, so it is negative 0.2. Then we have 0.3, 0.8, negative 0.2, and negative 0.7. We multiply these 2 columns of deviations. So 14 multiplied negative 0.2 is negative 2.8. Then we have 25.2, 139.2, 21.2, 116.2. To compute the variance of x, we need to find out the squared deviation scores for x. So the last column, we square each deviation score of x. 14 square is 196. 84 square is 7056. Then we'll have 30276, 11236, and the last one is 27556. Then we compute the sum of the cross product, SP or SSXY, the same thing, sum of the cross product. So we add this column together, we will have 299. With the sum of the cross product, we can find out the covariance. It is 299 divided by n minus 1, which is 4. So it is 74.75. Then for the last column, we need to find out the variance for x. So we add this together. Sum of the square for x is 76320. Then variance of x is 76320 divided by n minus 1, which is 4. So it is 19080. With this numerator and denominator, we can find out the slope. 74.75 divided by 19080, it is 0.004. Then we need to find out the intercept. Intercept equals to mean of y minus b multiply mean of x. We know mean of x and the mean of y, so the intercept is 3.2 minus 0.004 multiply 616. Okay. Now we can write out the regression equation. Y hat equals to 0.004 multiply x plus 0.736. So that is the regression equation of this regression line, best fitting line for the data. As you can see, the intercept is the value of y when x equals to 0. So this is the intercept. It is 0.736. The slope presents the slope of the line. Then we mentioned that this line always crosses the mean of x and the mean of y. Mean of x is 616. Mean of y is 3.2. Therefore, the line crosses this point. Then we use this line to predict the y value. For example, if somebody scored 500 on SAT, what is the predicted GPA for this student? We can use this line to predict this student's freshman GPA. When x is 500, then what the predicted y is. Using the equation, predicted y equals to 0.004 multiply 500 plus 0.736. So we predict this student who scored 500 on SAT would have a GPA of 2.736. So that's how to compute the regression equation and how to use the regression equation. Now I have a couple of questions. First is, what is the function of a regression line? The function of the regression line is that with a given x, we can predict y. Another question is, what is the problem of using the regression line to predict y? Yes, there is an error. The error equals to the true y minus the predicted y. Now you can take out the in-class exercise. For this question, compute the slope and intercept and state the regression equation. After you finish this question, you can move to the next section of the lecture.